Now, one of the number one targets for us when we find out a set of services we're attacking are hosted in the cloud is what we call the metadata API layer. Effectively, it's a layer provided by all of the cloud providers. They've all agreed on a very similar format for this as well, which basically shares system environment information. So I can say with some confidence that I didn't send that first request. It came from the host that I was compromising. If I look up that IP address, I can see that it's owned by Google. So I am probably compromising a host that's operating under Google Cloud. The header requirement is not present. Now, this was supposed to be deprecated in December, but it hasn't been. So I'm now going through the service through the endpoints. I found one called service accounts. I'm going to look inside a service account called Terraform Robot Storage, and I found one called token. And if I look inside that, that is a temporary service token, and that's how easy that was to retrieve. Now, if I do a very similar thing, just show you in the browser as well. Here's another one. This one's hosted in GCP functions. So instead of being a web app hosted within GCP, this one's hosted in functions. We do the exact same thing. There's another IP address that's not mine. And by asking it to proxy 169.254, I found compute metadata, and I'll follow the exact same steps, go through v1, b1. Just stick that at the end, and I'm just going to fast forward to the end. And again, we pulled out an access token just as easily. So we can do that both from a web app and from functions. And now very, very quickly, we're going to skip across to another one. This one's hosted on AWS Lambda. As I mentioned, AWS Lambda doesn't have access to the metadata API. So this one isn't rendering the page, but if we look inside, we've done what'smyip.org, and there is another IP address. Not quite so easy to see it in all that code, but it's there. And what I've attempted to do is access the metadata API, and I've received a error connection refused because it doesn't have that access. However, fortunately, if I take this a step further, we've got something called directory traversal or path traversal, which basically means we can access files and directories outside the webroot folder. So we manipulate some variables, and we can potentially reference files on the file system of the host. Whether that's absolute file paths or using ... slashes to basically go up one directory, and effectively browse the file system. And if we manage to exploit this, we can read and execute files on the victim host. Now, one of those files on a Linux file system is your environment variables. So this is where we were a minute ago. I'm now going to say, show me file etc password. And it's going to show me the contents of the user list file for that host. Now, if I do the same thing, but instead I look for file proc self environ, just as part of the curl request, you can see down here we've received a bunch of environment variables back, and we'll just quickly highlight. We have got an AWS secret access key, we have got an AWS access key ID, and we've got AWS session token, and that is everything we need to gain access using the Amazon command line tool. That is a full set of security credentials. The final one I'm going to show you is remote code execution, which is the most complete exploit, really. We can now run code on a system. So generally speaking, this occurs because of improper user input validation. Having gained access, we can run code, we can run commands, we can steal data, we can do pretty much anything. So it's a slightly different application. This one's Web App 2. I'll give away that it's hosted on Azure, this one. And you can see that each of these diagnostics tools that seem to be here, what they're doing is they're changing what's in the URL up here. And it looks like it's effectively a bit like a web shell. So you would kind of hope that this sort of diagnostic page wouldn't be exposed to general users, but it happens frequently enough. And so what we're going to try and do is we're going to overwrite that. And if I run uname A, sure enough, my command gets run. So I'm going to do a quick command. This weird dig command here reveals the IP. And again, it's not my IP, so I'm definitely able to get it to go off and access things. Now, because I've got full code execution, that means, you can see this one's owned by Microsoft, so that's Azure. That means I'm actually in a position to send full curl requests with headers, which means I can send the header for Azure, it's metadata true, which means I'm able to send the full metadata request, including the header, and get a proper response. So we're going to send that, and certainly we are inside. I'm going to do the same thing with curl requests. We're now sort of in curlception because we were sending a curl request to web app 2.victim.cloud, and the command is to send a curl request with a header through to the metadata API. The formatting for Azure's is slightly different, but that doesn't matter too much. That's what's happening. And if we just keep on adding the endpoints, we can browse through that. And again, you could pull out some tokens and various other things.